The science developing metal organic framework.
Metal organic frameworks.
MOF.
MOFs.
Metal organic frameworks, or MOFs.
The MOF.
MOFs stand for Metal Organic Frameworks. You're probably a little sick of hearing about them because everyone has been talking about them since they won the Nobel Prize in Chemistry. But really anything could win the Nobel Prize in Chemistry, so why should you care, and why does everybody seem so excited about them? First of all, they're just a really cool idea. They are man-made substances we have designed from an atomic level, and as their name suggests, they contain both metal and organic molecules. We make them by combining metallic ions in specific organic molecules in order to create new molecular structures. These structures can serve super specific purposes. The people that won the prize were Susumu Kitagawa, Richard Robinson, and Omar Yagi for creating an MOF that has a ridiculously large surface area in a very small volume. This has a lot of use cases, but the application that has been most discussed is in regards to fighting climate change by absorbing greenhouse gases. Hi, I'm Samin Marco, and I make videos about marine biology. If that interests you, you can subscribe right now. In this video, I'm going to compare how marine ecosystems, specifically seagrass meadows, and MOFs compare in the ways that they help fight climate change. Before we start, here are all the timestamps you need to figure out what's going on in the video. And before I forget, there will be a test at the end of the video, so make sure you are taking notes. Anyways, in case you forgot, we are currently waging a battle against anthropogenic climate change. The greenhouse gases released by humans in our activities has created a greenhouse effect, which has increased the average global temperature beyond what it would normally be at. This is a long-term change, but we already see the effects on the climate today, from higher average temperatures to once-in-a-lifetime climate events happening multiple times in one lifetime. There have been MOFs designed to specifically capture these greenhouse gases. And when I first heard about this use case, it really interested me because I had always heard about the ecosystems on Earth being a way that we could capture carbon. And this seemed, at least the way it was pitched, to be a very direct parallel to that. As someone who is interested in marine biology, I know that the ocean is one of these carbon sinks, and I was wondering how MOFs would compare to that. The MOF CALF-20 is a promising candidate for carbon sequestration due to its long lifespan and simple creation process. MOFs like CALF-20 capture carbon through bonding sites. These MOFs then have to go through chemical processes in order to permanently store that carbon. An MOF's lifespan refers to how many times it can kind of go through that cycle. It has been proposed that these kinds of MOFs could have industrial applications through catching carbon emissions and filtering them out. This would reduce the amount of greenhouse gases we are adding to the air and stop us from making climate change worse than it already is. In an article by Raphael Schneider titled Carbon Dioxide Capture and Conversion Using Metal Organic Framework Materials, a Comprehensive Review, he talks about some of the challenges with using MOFs to capture carbon and how it could be implemented realistically. He provides this image to kind of walk through the general idea of the process that would be used. The article really outlines two main methods of carbon capture for MOFs: physical capture and chemical capture. Physical capture entails having a very large surface area and just absorbing a bunch of carbon. I'm not even talking about like my room kind of surface area. I'm talking about a football field and a sugar cube kind of area. Chemical capture involves chemically converting the carbon in the air into another element through using specific bonding sites on an MOF. Many MOFs have struggled to balance absorption and stability, which has been a challenge in finding a way to implement them into carbon sequestration. However, recently, MOFs like CALF-20 have been able to overcome some of these hurdles, showing great promise for future use cases. But this isn't a chemistry channel, so I'm going to stop the dive into the MOFs here before we get lost in the weeds. Returning to marine biology, let's look at a different type of carbon sink: seagrass meadows. Seagrass meadows store carbon very differently than MOFs. While MOFs actually capture and store CO2 either physically or chemically, seagrass meadows use photosynthesis to absorb CO2 dissolved in the water and turn it into sugar. In a study led by Michael N. Gathaiga, it was reported that 90% of the carbon stored in the seagrass meadows that he studied were stored in the sediment. About 50% of the carbon in the sediment is externally sourced, and the seagrass is able to retain that carbon because the grass slows the flow of the water. The degradation of these ecosystems could worsen climate change. through the sediment being disturbed and releasing the carbon that it stores back into the carbon cycle. This carbon could then enter the atmosphere and worsen the greenhouse effect. This is one reason why conservation matters so much. And so if you want to get involved, here are some ways you can. NOAA has multiple projects going on like SCAR maps, which by the way is an amazing acronym for Seagrass Conservation through Actionable Research Management Areas for the Prevention of Scarring, that are working to understand and protect seagrass ecosystems. Seagrass Net is a global organization that I highly recommend you check out if you want to learn more. Additionally, all the links will be in the description that I used to research this video, and some other links if you want to learn more about MOFs or seagrass meadows. Thanks for watching. Like and subscribe. Share this video with your favorite MOF or seagrass enthusiast, or someone who's just confused that you want to inform. And it's quiz time. No need to stress and feel free to pause, but if you want a challenge, try and go through it without pausing. Question 1. What is a MOF with promise in carbon absorption? The correct answer was CAF-20. Question 2. Where does the majority of carbon get stored in seagrass meadows? The correct answer was the sediment. Final question. What is my name? The correct answer is Samid. Thanks for participating, and let me know if you have any questions.